Thanks for joining, everyone. For anyone that's watching the recording, or for anyone on this call that needs a little bit more context, what we're going to do today is a quick demo of the initial POC for a Kubernetes operator to manage V1 Pocket nodes. So just as a quick intro, my name is Richard Lander. I work at a company called StakeSource, and I'm collaborating with folks from the various Pocket teams to work on this project. I have worked with some other folks in the community building a tool called Operator Builder, which is a tool that accelerates the development of Kubernetes operators. And so I'm going to use that tool today to generate the source code for a Kubernetes operator. And then the intent would be that I'm going to essentially donate that code to Pocket Foundation, and then we'll just jointly maintain and develop the Pocket operator, which will greatly improve the user experience for people that want to spin up Pocket nodes, V1 Pocket nodes, that is, on Kubernetes clusters. So with that context, I am going to share my screen and get started. All right, so you should just be able to see a terminal, and Google Meet is confirming that for me now, and you can. Okay, good. So for anyone that is on the call, I'm going to be tearing through a lot of content pretty quickly. We have a lot to cover, and we won't fit everything in an hour, but we'll fit in as much as possible. Please do interrupt with questions if you have any as you go along. I'd rather make sure and clarify things that sometimes I forget to touch on and explain. Sometimes I just take some of these things for granted. So if it feels like I've skipped over anything, or there's something that doesn't make sense, just give me a shout. Just interrupt me as I'm babbling, and I'll clarify. So just a quick overview of what we're going to cover. So first of all, I'm going to do a quick review of some definitions of terms. Some of you may be familiar with because they're just Kubernetes operator terms, but some of them are also specific to the implementation with Operator Builder. Then we're going to use Operator Builder to generate the source code from a set of configurations that I have, which will be the source code for a working Kubernetes operator. And then we're going to use that operator to spin up some validator nodes in a local development kind cluster that I have. And then after we do that and do a demonstration of how that works, I'm going to do just a quick orientation of the most important things in the code base of the operator itself. And then I'm going to circle all the way back around to the configurations for Operator Builder that I use to generate all that source code. It'll make more sense if I do the demo of the code generation and everything first. Then you'll have some points of reference for when we look at the configurations. And then finally, I'll touch on some operator development lifecycle stuff that'll be helpful for next steps, I guess. So for definitions, it's important that we just have a shared understanding of what we're talking about with this stuff. So first of all, let's talk about just Kubernetes operators. For anyone that is interested in Kubernetes operators and wants to learn more about it and hasn't read through this page in the Kubernetes documentation that's titled The Operator Pattern, I recommend it. It's useful. But I'm going to summarize a couple of definitions here really quick, just to make sure we're all on the same page. So a Kubernetes operator, in my view, the best way to define a Kubernetes operator is that it is an extension to the Kubernetes control plane. And it consists essentially of two primary pieces. One is a custom resource, and the other is a custom controller. So the controller is just a piece of software that runs in a Kubernetes cluster and manages a set of concerns, whatever you program into it. For context, the core Kubernetes control plane consists of an etcd data store, an API server, and then a whole bunch of core controllers, like the scheduler and the deployment controller and the stateful set controller and so on and so forth. And these are simply containerized workloads that run in the cluster and manage a set of concerns. And we're developing a new piece of software that uses many of the same upstream libraries and it's just another Kubernetes controller. It's just a natural extension of that control plane. And then the custom resource, we're actually going to use two custom resources in this case. But a custom resource is just essentially a new API object that we add to the Kubernetes API that forms like the data model for configuring the things that you're managing with your operator. So an operator is an extension of the control plane. It consists of a controller and a custom resource. And I just want to make sure we're all on the same page with that. So now, in terms of some operator builder specific definitions that I'll be using along the way, this is actually a good illustration of an operator as well. This is a diagram I created to explain the V0 pocket operator that I developed earlier in the year that I've been using. And here's the custom resource component of the operator. It's a pocket resource. And this is the pocket controller, which is the controller component of the operator. You're going to hear me use terms like parent and child. The pocket resource, the custom resource, is the parent. When an admin, a user, creates a pocket resource, the controller will get notified through this watch mechanism and then create a bunch of children which are spawned off of that pocket. So it takes the configurations out of that pocket resource and it uses them to inform how to construct all of these child resources over here on the side. So if you hear me saying parent and child, that's just all it refers to. Is the parent is the custom resource and the child is all of the resources that are created in response to the creation or update of that resource. Another term that you'll hear me using, other terms, workload collection and component workload. Essentially, Operator Builder takes a configuration for a workload and it generates the source code for an operator to manage that workload. So a workload collection can include, not necessarily, but can include Kubernetes resources that get deployed the same way a component workload does. The reason we have a workload collection is so that component workloads can extract configurations from the collection resource and can have dependencies upon one another. We do also support just a standalone workload for really simple use cases. But in the case of the V1 pocket validators that we're going to spin up today, we're using this collection and component concept because while we only have one component workload, we can spin up many instances of that, which is a validator. And those validators will derive some of their configuration from common configurations that apply to all of them. So that's going to become more clear as we go through this and you see it unfold. But I just wanted to introduce those terms so I didn't forget to define them as I was talking later on. So with that, I'm going to get straight to the code generation. And again, I'm going to generate the code, and some of this is going to be a little bit mysterious right off the bat, like how are you generating this much code? Like I said, later on, after I do the demo, I'm going to circle back around and go through the configurations that illustrate how we generate the source code. So I'm going to start here in an empty directory. There are a couple of hidden directories because this is an initialized Git repo. And in this .operator builder directory, I have all of the configurations I'm going to use to spin up the source code. The reason it's in a hidden directory is because under the hood, we use a project called Kubebuilder. For anyone that hasn't encountered Kubebuilder, Kubebuilder became, over the last few years, the state-of-the-art for building Kubernetes operators. And Operator Builder, which, by the way, this is the repo for Operator Builder, and you need to, in order to use Operator Builder, you need to install the CLI, so you can just go to the releases page and install it for your architecture here. But Operator Builder is, like the description says, it's a Kubebuilder plugin. So it uses Kubebuilder under the hood. Kubebuilder creates a framework for an operator. It doesn't implement any controller logic. It doesn't implement any API definitions for the custom resource. Operator Builder extends Kubebuilder by ingesting a bunch of configurations in Kubernetes manifests and then building an operator based on that. So because we use Kubebuilder under the hood, and Kubebuilder expects to generate code into an empty directory. However, it does tolerate hidden directories. So we put all of the configurations in the Operator Builder directory or .operator builder. And also, if we want to keep any files between code generation iterations, we can put them in there because when we regenerate code, we just blow everything away and regenerate it from scratch. So I'm going to navigate into that operator builder directory. And I have, among other things, a makefile in here to just speed up some of the common operations. And we're just going to use that right out of the gate. And there is a make target called operator init. So what that's doing is in the parent directory, we're navigating to the parent directory, and we're running the operator builder init commands. So I have the operator builder CLI installed, obviously, and the init subcommand initializes the source code. We pass into it a flag for the workload config and point it to this workload file. And the other flags really aren't very useful to talk about. But what that does mean is that if we look at the parent directory now, we've generated everything that you see in here now. And these are the things that are common to virtually every implementation of an operator. It doesn't include any controller logic yet. It doesn't include any API definition yet. But the next make target is operator create. Yeah. Now, what this does is this issues a command, again in the parent directory. We're going to use the operator builder CLI, and we're going to pass in this create API subcommand. Again, we're going to pass it that same workload configuration, which we're going to look at later to see what is in there. And a couple other flags just tell operator builder and subsequently Kubebuilder to spin up the source code or to generate the source code for a controller and a resource. Sometimes you do want to do one or the other. 90% of the time, better than 90% of the time, you want to do both for most applications. And so now if we look in the parent directory, we've got even more source code, and actually we have the complete source code for a Kubernetes operator, and it's ready to demo and run and spin up Pocket Validator nodes. All right, so we need to do a couple other things, but real quick, I have a fresh kind cluster created. Yeah, just a basic kind cluster that I generated, built this afternoon. And in here, you just see the standard namespaces that come with a kind cluster. One thing that we do need as a dependency for the Pocket operator is the Postgres operator, so that we can use it to spin up the database instances for each of our validator nodes. And I just have that in this dependencies directory here. I just have some manifests, some static manifests to deploy those, the Postgres operator. And I think I just created, yeah, operator dependencies is a make target I created just to apply those manifests. So now, yeah, we have a Postgres operator namespace now. So the Postgres operator is ready. Now, this is just a convenience for development. We wouldn't use this in a production cluster, of course. We'd have other mechanisms to install cluster add-ons like the Postgres operator, but this is useful for testing and development purposes. The one last thing I'm going to do is I generated a set of sample manifests, or I developed a set of sample manifests that illustrate how this thing works, how the operator works. And I'm just going to copy those over, samples, yeah. And so I just copied out of the samples directory that I kept in here so that it survives blowing away all of the source code. It just copies it into this config samples directory in the, which is from the root of the operator repo. All right, cool. So we now have the source code for it. We're actually ready now to run this operator against my kind cluster, my local cluster, and use it to spin up some Pocket validator nodes. When we installed the Postgres operator, we got one CRD, which is the Postgres CRD, which the Postgres operator installed. We also need the CRDs for the custom resources we're going to use for these Pocket validator nodes. So just to distinguish a couple of things, in the primary project for the Kubernetes operator, we have a makefile with a bunch of make targets, as distinct from the make file I have inside the .operator builder directory. I just want to distinguish that because now I'm going to run some make targets for that actually come with Kubebuilder. Kubebuilder gives these to us as a convenience. And the first one we're going to run is make install. And that is going to install the CRDs. So as a part of this code generation, it includes the CRDs, the actual custom resource definitions, which live in this config directory. And you can see that we've just created these 2 new CRDs. And if I come over here and run get CRD again, we now have our Pocket set and Pocket Validator resources. And I'll explain what they do as we go along. But in order to deploy Pocket Validators, we're going to use those 2 custom resources and just apply them to the cluster. All right, so the other make command that we're going to use that comes with Kubebuilder is make run. Now, what make run is doing is it's compiling the source code and running it against my cluster using a kubeconfig file. So this is the functional equivalent of compiling the source code, building it into a Docker container, and then deploying that Docker container into a cluster and running it in the cluster, which is what you do when you run it in production. For development feedback loop speed, I'm just running it from my local machine against the kind cluster using my kubeconfig so that I can start and stop it and make adjustments more quickly as I'm going along. So in this bottom left pane here, I'm running the Pocket controller for the Pocket operator. And as we conduct operations, you'll see more log output as it goes along. All right, so at this point, I'm just going to split this pane over here, and I'm going to take a look at the first Pocket custom resource that we're going to deploy. And this is the Workload Collection resource, which is called a Pocket set. So this is a very, very simple resource. It has no spec whatsoever. Now, over time, we will add things into the spec as needed. But for the time being, we're creating a Pocket set that is just called primary. And when we create this resource, what's going to be created in the Kubernetes cluster are all the common resources that are going to be used by all of the Pocket validators that we spin up. So that, specifically speaking, is on a namespace. It's a config map, a Genesis config map. And to be honest, I don't know much about what the Genesis config map does. I just know it's needed. And it is mounted by each of the validators, the Pocket validators. And one more thing, a service. And that service is essentially a Kubernetes headless service that provides a proxy to all of the validators that live within this Pocket set, that are included in this Pocket set, okay? So now I can just use kubectl, and when I run K, that's just an alias for kubectl, apply that file, which is config samples Pocket set. So when I run this, the first thing you'll see is log output from the controller, because it's watching the API server, and as soon as it gets notified of a Pocket set resource, it'll go ahead and do the things that it needs to do in response. So we can see from its log output that it's created a namespace, it's creating resource service, and further down here you see it's creating a config map as well. So if we check our cluster, get namespace, we can see that we now have a primary namespace, and it's named directly after the Pocket set. So all subsequent Pocket validators that we create are going to be created in that primary namespace. And if I'm going to set my namespace to primary and then say get service, we'll see our primary validator service that's in that namespace, and get config map, which gives us our primary Genesis config map that all of our validators are going to load. And that is what was created in the cluster as in response to creating that Pocket set. And again, these are all the things that are common to all of the Pocket validators that we're going to create next. All right, so next thing we want to do is have a look at one of these validator resources. So in that config samples directory, we have all of the samples of a Pocket set and then 4 distinct Pocket validator resources. So let's have a look at one of the Pocket Validator resources. All right, so this one is called V1 Validator 1, and as you might imagine, the others are called V1 Validator 2, 3, and 4. And I'll just briefly go over what lives in the spec for a Pocket Validator at the moment. First of all, we inform the controller that this validator belongs to the primary collection, which refers back to our Pocket set, of course. We're going to say we just want one replica of the Pocket Validator itself, which translates into how many replicas we configure in the stateful set. And then we want just one database replica, which translates to how many DB replicas we tell the Postgres operator we want. We inform the controller of what image we want to use to run the Pocket Validators. And then we have a hard-coded private key in here. This is just a development mechanism, testing and development mechanism. Long-term in production, we wouldn't want to define private keys this way. But each of the Pocket Validators does have its own distinct private key, so I'm defining it this way for the time being. Long term, we just want to generate the keys in the controller as it's spinning up the Pocket Validator nodes. So just generate the keys and then use the keys for those validators. At least that's how I imagine it going forward too. And then we've also got a peers configuration that it occurred to me this morning, we might be able to abstract this into the spec for the Pocket set. And that occurred to me because the peers are identical among all of the Pocket Validators. So that being a common configuration, it might make sense to put it in the collection resource, but we can flesh that detail out later on. For the time being, it just has the same peers configuration in each of the Pocket Validators. So now we can apply that particular custom resource. But before we do, this command is just an alias for K9S, and I'm just going to run that as essentially a watch for pods in that primary namespace. So again, we have the primary namespace, we have a config map and a service, but we don't have any pods in there right now because we haven't spun up any validators. But that will soon change. All right, 4:30 already. Okay, so samples, nodes. All right, so now we're going to apply this resource that you see here. This will get picked up by our controller, and it's registering that that thing is being created, and now it's spinning up the different pods. First of all, you can see the Pocket V1 Validator 1. That's the actual Pocket Validator, and this is obviously the database for that validator. That database was spun up by the Postgres operator in response to us. The controller created a Postgres resource. Now, I know from having tested this earlier that the image for the validator pulls faster than the database image. And what that means is that when the validator does start, it's going to throw an error and it's going to start the crash loop because it takes longer for the database to pull its image and start up. And of course, the validator can't run until it can connect to its database. So you'll see it throw an error and crash loop, and we'll look at the logs to confirm that that's what the problem is. But it will not be able to connect to the database, obviously, until the database starts up. Now we have one wrinkle with the password, which I'll get into in just a minute, the database password, that is. So subsequent to the database starting up, it will continue to throw an error, and it will be for a different reason, which is just failed authentication. And this is a wrinkle for which we need to develop a solution to, and that is this. So if I create a little more space here, if I get the config map that is generated for this particular Pocket Validator, which is the V1 Validator config, this one right here, I'm going to output that to YAML and then take a look at it. Okay, so this is the configuration. You can see that the controller inserted the private key that we supplied up here. It inserted it into the config map for us. It also inserted the peers for us. And then when we get down here, this Postgres URL is the thing. that is in question. So this URL means that our user is Validator, our password is Postgres, which is just obviously a hard-coded placeholder. And then v1 Validator1 database is actually the name of the service. That's the host name. But in Kubernetes terms, it's the name of the service so that it can connect to the database. And then obviously the port and then the database name. So the problem is that the Postgres operator, when it creates a new database, it generates a brand new password for each of the users, which is best practice. It's a good idea. The way it works is what we want. It generates a new password for each user and stores that as a secret. And if I quit out of this and say k get secret, you can see the 3 secrets that were created by the Postgres operator. And this is the one for Validator. And if I get that secret, yeah, there it is. So if I retrieve that secret, output it to JSON, and then pass it to pull out the password and then decode it, you'll see that the password is not Postgres. It's this thing that was generated by the Postgres operator, right? And you can see up here the validator has started, but it's crashed. And if we get the logs, you'll see that it's because it can't connect to the database. And you'll see it can't connect to the database, and that's because the database is still creating. Once the database comes up, we'll see a different error. So anyway, getting back to that config map problem, we have Postgres in there. Now the trick is we have a bit of a chicken and egg problem. The controller doesn't know the password until the Postgres operators created it. So there's one of 2 ways that we can solve this. One is that the controller, we can program the controller to go get that password and then insert it into this Postgres URL and so that it'll have the correct password. Alternatively, and this would require a change to the Pocket workload itself, instead of consuming, or in addition to consuming this Pocket Postgres URL, I would suggest, and this would be, I guess, the cloud native way to do it, is optionally allow us to pass in Postgres user, Postgres hostname, Postgres database name, and then allow us to mount the secret that the Postgres operator created for us. We can expose that as an environment variable, and then Pocket can internally consume those different elements and construct the URL itself. And that way, all we have to do is have the controller mount that secret, and then the Pocket validator will have the secret that it needs to connect to the database.
Yeah, that totally makes sense. Okay, I just want to say that we talked about this and we brought this up in the past. We eventually want to add support for configuration parameters overrides either via environment variables or CLI arguments.
Yep.
And that way we kind of support not only like operator use case, but also like Helm or other use cases, because like there are obviously other configuration parameters that needs to be changed. Yeah,
wonderful. That's great news. Great. So once that's implemented, we'll change that to do exactly that, and just mount that secret that is generated by the Postgres operator, and then we're in business. We'll just expose it as an environment variable. And for what it's worth, we'll probably want to do the same thing with the private key, but we don't need to worry about that for the time being. All right, so you can see that our database is now running and that it's still throwing errors. And if we look at those logs again, we'll see that its password authentication failed for exactly that reason I was just talking about. So I just wrote a script that will go get the password out of the cluster secret and then update that config map. But before I do that, I'm going to deploy the other validators. So so that's 2. And you can see as I'm creating these resources, the controller is responding by spinning up all of the child resources. So again, this is the parent resource, and these are the child resources you can see spinning up in the cluster. And they're going to exhibit the exact same behavior. Once the databases come up, which will be much faster now that it's pulled the image, I'll just run this script, and then we'll at least validate that the Pocket Validator nodes are running as expected once the password is fixed. So in the Operator Builder directory, I have a hack directory, and in here I just have a script. This validators file just contains a list of these validators, and I can run a for loop on that and update the DB pass. And because it wasn't originally deployed with kubectl apply, I have to run it twice. And I just made a mistake that I'm really glad I made, because this is a really important way to trip yourself up. What I just did is I updated all of the config maps. If we look in that script, you'll just see a kubectl apply to the config map to fix it and to put the proper database password in there after getting it out of the cluster secret. The problem is if you look at the output from the controller, it's reverting all my changes. It's the controller's job to keep it in a certain state, and if something changes it, that controller is going to revert that state. So you can cause yourself a lot of confusion by doing what I just did, but luckily I've stubbed my toe on that enough times to realize that what happened. So if you need to make any changes, you don't want to do this in production. Sometimes you have to in an emergency, but I'm disabling the controller. You can see I just shut it down so that I can make changes to those resources in the cluster without it reverting the changes on me. So I'm going to rerun that script. Now the config maps will be changed to the correct password, and I'm just going to now delete these existing pods, these validator pods, so that I don't have to wait for them to start up again. Although I can see one is doing it now anyway. So I'm going to delete each of those pods, and then the underlying stateful set controller is going to spin those pods back up again, and we'll have working validators. And I'll just tail the logs on one of these in just a second, just to confirm that that's the case. And you can see now that we don't have any database connection problems because the password's been fixed. And I think this is about the extent of the logs that come out at this time. And obviously, I don't have much understanding of what is going on here because I haven't worked on this validator project at all. But everything seems, there are no errors, so it seems to be working as expected at this point. And I would imagine that we'd be able to test through that Pocket Validators service with some kind of client calls to confirm that. I just haven't gone any further than validating this. But as you can see so far, we've used the Pocket Operator and just a handful of custom resources to spin up the various validators and their corresponding databases. One other thing, Dimitri, I think I asked you this in Discord, but I just wanted to double check this. The intent long term is that each validator node would have its own dedicated database instance. Is that a correct assumption?
Correct.
Okay.
Yes, and in the setup that I sent to you, we were using different schemas, which is essentially the same thing. They just like technically the same database, but namespaced. Like all of the tables are namespaced.
Yeah, exactly, and that makes sense.
Can I actually jump in here?
Yeah, of course. Go ahead.
So there are two aspects to how many database instances we actually need here. At the moment, kind of this work, which I just have to say is freaking awesome. Basically, we have a single Postgres instance, and we're using separate schemas because for local development, we just have one Postgres DB, and everyone's connecting to it, but we need essentially complete separation using the same schema.
Yeah,
the same SQL schema. So we're using different Postgres schemas. Now, in production in the future, one of the things we want to enable is kind of stacking nodes. So you would have multiple validator nodes or multiple servicer nodes, essentially going back, all being backed by a single DB. This is actually very similar to the lean Pocket proposal that's being implemented in V0 right now. I don't think this has any actionables or impacts at all on what's done here, but it's just kind of important to note.
Yeah, that is good to know. And so basically at the end of the day, what I think we want to do is be able to configure a Pocket Validator to use any database. whether that be a shared database or a dedicated database. We just need both of those options, right?
Exactly.
Yeah.
And
Cool.
could I actually jump in with another question?
Of course. Go ahead.
So we have the validators running right now. And did you by any chance follow the development guide in GitHub, or have you taken? No. Okay.
Oh, I did not.
Because we also, we don't have an RPC spec yet, but we do have a client that you can kind of start up that can kind of broadcast commands. So it'd be really interesting to see as a next step, also launching it and then seeing the kind of the blockchain make progress once we set some transactions.
Yeah, 100%. And I just don't have enough familiarity with that part yet, but that is the next step. Totally agree.
Dimitri and I can definitely help with that from.
Awesome. Really cool. Good deal. All right, so how much time do we have? Okay, we've got about 15 minutes. I'm going to do just a really quick orientation to the code base because it helps in just grokking. So what I'm going to do, I have this code pushed to a public repo right now, and I'm happy to donate it to your repo at any time that you see fit. And for anyone that does look at the code base, I just want to do a quick outline of a couple of important things. We obviously have a Docker file that's ready to go to build a container image for the Pocket controller. And the important things in the code base, the most important things, are in the APIs directory. And if we look in this APIs directory, this is where our custom resources are defined. And this is also where the child resource definitions live as well. So if you needed to, for example, make a change to the stateful set and the way the stateful set is configured, you could go directly into here in Pocket Validator, and in this file, you'll see the definition of the stateful set. So if you wanted to change any part of the stateful set in any way, shape, or form, you can do it directly here. The other thing that's really important in the code base lives in the controllers directory. And this corresponds to what I said. The two primary components of an operator are the custom resource, which is defined in the APIs, and the custom controller, the logic for which is defined in controllers. So in controllers, there are actually two separate control loops that run in the same workload, one for the Pocket Validator and one for the Pocket set. So you can modify the logic for each independently. And in the phases, we have the different steps that each reconciliation loop goes through, and each phase is distinct. So you can add custom phases, you can make changes to them. In this case, we're actually using phases that are defined in an external library that we call Operator Builder Tools. But in the interest of time, I won't dive down that rabbit hole too far. And the other thing is in the config directory, we have a bunch of samples that can be used. First of all, in the samples directory, these are the samples that we deployed today. But the rest of these resources and customized overlays can be used to very readily deploy an instance of the controller containerized into a cluster. All right, now with that said, I should take a quick dive into the Operator Builder directory, because this is where all the configurations live that generated all that source code. So I'm going to kill this. The first thing that we need to look at is this workload file. This is the primary configuration for Operator Builder. So if we look at that workload file, this is a workload collection configuration, and this looks a lot like a Kubernetes resource manifest, but it's not. It's just force of habit. This is strictly a configuration file for Operator Builder. It's nothing that a Kubernetes API will understand. So this workload collection allows us to define the attributes of the API. So if we look at the sample manifest for the Pocket set, you can see that this is the kind and the API version are all defined here through the kind, the group, which is the API version, .domain/version, which is v1 alpha 1. Again, in the interest of time, I won't get into the companion CLI stuff today, but I will point out that the resources for the namespace, the service, and the config, that's in this case the primary namespace, and the service and the Genesis config, they're all defined in those files there. And if we open those up, you'll see that it's just a Kubernetes manifest. This is a working Kubernetes manifest, and it has these commented operator builder markers that inform how we construct the custom resource and some of the behavior of the controller. And I'm going to dive into what those markers do in just a little more detail on a better example. The other thing that's here is another workload definition, and that's for the component workload. It looks like this, and this is a component workload. Again, it has its own API definition. Again, it has some stuff for companion CLI, but the important part is it has this database and this validator resource. And if we open those up, database, and then validator, you see that we're using a Postgres custom resource to use with the Postgres operator. And then the validator includes the stateful set, the service, and the config map. And I'm going to talk just a little bit about how these operator builder markers work, because this is how we construct custom APIs and controllers. And this first operator builder marker here is a decent place to start. And if I bring up these markers help inform how this gets constructed. So in this case, we're saying that the value of the name for this stateful set should be taken from the parent's metadata.name. So this is the parent, and its metadata.name is v1 validator 1. So what that means is that get stateful set, they get named the same way. v1 validator 1, v1 validator 2, and so on and so forth. So the stateful set inherits the name from the parent custom resource, and that's how we inform operator builder that that's the outcome we want. Alternatively, and this is where we take a configuration from the collection, the namespace, as you know, that we used for everything was the primary namespace. So if we take a look at the pocket set name, that's where we derive the namespace, and so on and so forth. And then when we get to something else that's a little more specific, like the replicas, we actually take that from the spec pocket replicas or validator replicas. So we include a marker that says we want to use a field with the name validator replicas. It's a type int, and we can default it as well so that it's an optional field, and that's how it gets manifest up here. And what that looks like, and this is the thing that makes using Operator Builder save you so much time, is pre-Operator Builder, we'd have to go in and define in the source code all this stuff, right? And what Operator Builder does is it ingests this stateful set manifest, and it ends up, it generates, bear with me while I find this, generates this. And you can see that this stateful set, this is an unstructured resource from the upstream API machinery library. And we create a Kubernetes unstructured resource type that is a stateful set. And this variable substitution is just taking from the parent, which is an input into this function, along with the collection. You can see where we've put those markers, those operator builder markers, we now have variable substitution that help configure this resource. And if we go a little further down, we'll also see the same thing on the service, and then the same thing on the config map. The thing that's a little bit different and interesting about the config map is that if we go down here, config map, like this config.json file, is a value for this entire thing. So we use this replace mechanism to just find unique strings in here, like private key, and then replace it with the value that is in private key, which is a field from over here. And so what that looks like in the source code that gets generated is again, we're just concatenating strings at the end of the day to construct that config map the way we need it to be constructed. And so we can actually manipulate the contents of a config map, which is really important in almost every use case. So that's a little insight into how those configurations work. So if we take a better look at this, this directory, you can see that we have these samples that I need to preserve between nuking the source code and then the dependencies. But the real important stuff is in here. These are the resource manifests that get ingested into Operator Builder to inform how it generates all of that source code. Hopefully that makes sense. I know I rushed through that in order to fit it all in. The one other thing I wanted to point out is that we commonly go through two distinct phases of development for operators like this. The first is this phase, which is building these configurations, generating the source code, running it, and making sure that the behavior we get is what we're looking for. And generally speaking, we'll iterate that on that, any number of times to get it right. Oftentimes, we'll just tweak Operator Builder markers and then regenerate source code to make sure that the result is what we want. But then at some point, we get out of that loop of generating code based on configurations, and we leave that behind and start just maintaining the project and developing the code as we would with any other software project. And that just depends on the project. Sometimes it's a day, sometimes it's a couple of weeks, depending on the size of it. But we're down to about 5 or 6 minutes left. I did want to stop and allow anyone to ask any questions and also talk about next steps, how you'd like to proceed from here.
Yes, thank you very much, Richard. I love this. It looks really great. So is my assumption correct that we can follow Kubebuilder book as a reference to extend this operator to allow like additional configurations via spec or possibly via annotations of other resources?
Talking about
that's the one.
Yes, 100%. Everything that's in the Kubebuilder book absolutely applies because, like I said, Operator Builder builds on top of Kubebuilder. So all it does is it creates a bunch of source code that you would use as a part of doing the Kubebuilder project.
Okay. Another question I have is the config structure is going to change shortly for the validators. There's an open PR with the new configs. And we actually just had a meeting today about managing local and developer environments. And it seems like we are going to introduce some config generation logic into the V1 clients, similar to V0 client.
Yep.
So what do you think the best way of handling this with Operator? I have one idea in mind, and we could import V1 Golang structures into the operator and reuse it. But now the operator would depend on the version of V1 code base.
Yep.
And if schema changes, that means that operator, like the new version of operator, would also have need to be released.
Yes, yeah, 100%. So first of all, obviously, we'll have to pin versions of the operator to versions of Pocket itself, Pocket V1 itself, because this is a piece of software that knows how to manage a piece of software, so it needs to be in sync in that respect. In terms of how to handle that config generation, I'm not sure right off the top of my head. I'd have to get my hands on it and try it out. And it sounds like you have some thoughts around that already, Dimitri.
Yep. I have not tried it also, but yeah, I understand that is a tricky problem to solve anyway.
Yeah, so using the config file generation, I'm not sure. Again, I'd have to toy with it and try it out and see how it works.
Cool.
So I mentioned, I think, yeah, okay. So I've pushed this code to this repository, which is public. and I'll throw it in chat if anyone wants to check it out. And you can pull it, fork it, play around with it as much as you want. If I could find the chat window. But again, I mean, I'm not sure where we should go from here. So one thing I will mention real quick is that being that Pocket V1 is under heavy development and a lot of changes, I imagine that we're going to stay in the code generation phase for the operator for a little while. And then we'll get to a point pretty soon as Pocket V1 stabilizes, then we'll be able to, break away from that and just manage the code base normally.
Yep, that makes sense.
Cool. Go ahead, Daniel.
Yeah, and in terms of next steps, I would say we have some pretty big config and Genesis changes incoming. So like on this big, this is probably going to be one of the biggest kind of transitions we'll have. So we will likely need your help there potentially, just kind of migrate what you have now. Afterwards, it'll hopefully be easier so that everyone else can do it as well. Yep. But I would also say, so that's kind of one big next step. Then the other big step is also trying to get the client running. So we don't have a proper RPC spec and a proper CLI to interact with the node yet. We will. But even before we have that, we already have the mechanism to kind of trigger transactions and trigger consensus logic within the validator network. So I think really seeing that will kind of put everything together. Those are kind of the two biggest pieces from really putting like the first bow and tie on it. But other than that, I would probably defer to Dimitri on figuring out what the next steps in terms of having this be part of our primary main workflow, or whether that's the right path right now.
Yep, I agree. That makes sense. By the way, when I sent the proof of concept deployment to you, Richard, I did try to log in via client, and I was able to start the blockchain. So this setup must be working. I'm pretty sure it works.
Outstanding. So what I'll do is, if I'm going to go check out the Pocket Network Protocol repo and look for instructions on how to validate that part of it, and then make sure that this is behaving as expected, and then we can just. I'm happy to collaborate around this repo until you'd like to move it somewhere else. But one thing that I'm interested in input, if you have any, is on things like naming conventions around words like pocket set and things like that. I'm just not sure if they seem intuitive or appropriate to your team. So I'm all ears if you have suggestions on things like naming.
Yeah, that is very fair. For example, Genesis, I can see how we can maintain different like development networks or different test networks, and we could actually create the Genesis files for different networks via operator. And that would require some, of course, logic. But yeah, we can definitely do this, and I'll look at how we can maybe change the names, or for example, I'm personally not sure if namespace should be part of Pocket Set, for example. So stuff like that, we'll figure it out.
Yeah, 100%. All right, cool. Well, we're at time. So what I'll do, Dimitri, is I'll coordinate with you in Discord. I already have a couple things in mind that I can tweak and improve on this, and I'll continue to play with that, and then we can coordinate in Discord on next step.
Sounds great.
All right, awesome. Cool.
And I'm also going to show the hashtag V1 Dev channel that we have in the public